The next move to another problem, same type problem. So you can pause and try to solve these two problems. So a rock bed has a true dip of 35 degree. That means theta is given 35 degree. The apparent dip is measured. Sorry. This is the problem from previous part of the video. So it is the direct tan calculation, the apparent dip calculation. Sorry. So the true dip, it is given 35 degree, and dip is measured along hill slope making an angle 50 degree with the true dip direction. The apparent dip is measured along hill slope making an angle of 50 degree with the dip direction. Means it is given beta 50 degree. So you have to calculate the alpha. So here you have to read it carefully. The apparent dip is measured along a hill slope making an angle of 50 degree with the true dip direction. So we have discussed in the previous video that beta is the angle between the true dip direction and the apparent dip direction. So now we will calculate the apparent dip. We put the formula tan alpha equal to tan theta into cos beta. So theta is given 45 degree is 35 degree. Tan 35 into cos 50 degree. So alpha will be, take tan inverse 0.4500. You can take all these at 8473. So it will be 24.231. So you can write down 24.23. So alpha will be 24.23 degree. Next question, sandstone bed dips at 45 degree towards east and is exposed on a hill sloping 30 degree towards east. Both are dipping in the same direction. So bed dip 45 degree towards east, that means theta is your 45 degree. We'll use this from this symbol dipping in the same direction will show I equal to 30 degree. Okay. If the width of the outcrop measured as a slope is 100 meter, so W is given 100 meter. So we will calculate the true thickness T equal to W sine theta minus I. So W is given 100. Sine theta minus I, it will be 45 minus 30. So it will be 100, same sine 15. So let's see how it will be. .881 meter. So it will be 25.88 meters. Round up to 2 decimal. So let's move to next question. Sandstone bed dips at 40 degree towards north. So here theta is given 40 degree. It is, take this symbol, towards north, while the hill slope is inclined 20 degree towards south. So now they are dipping in opposite direction. So I equal to 20 degree, take opposite direction. The outcrop width is measured, W is measured 90 degree, sorry 90 meter, sorry. Then you have to calculate the thickness of the bed, true thickness. So we'll take here W sine theta plus I, because the beds are dipping, beds and slope are dipping opposite directions. So W it is given 90 into sine theta is 40 plus this is 20, no it is 60, 90 into sine 60. It will be 77.9422. Okay. So if you round up to 2 decimal, it is 77.94. 77.94. So now move to another type of problem. Here we will calculate the normal stress and shear stress that is produced during fracture or fault formation. So in this type of problem, you have just remember the formula. So you will easily calculate or easily put the value in the formula and you can get the answer. So if you want to understand completely, then we have to do a separate video for this, how these numerical these formulas derived. So next, you remember the formula. There are two formula for normal stress calculation and shear stress calculation. So normal stress is your sigma 1 plus sigma 2, or you take sigma 3, that is maximum plus minimum, divided by 2, plus sigma 1 minus sigma 2 divided by 2 cos 2 theta. Theta is the angle of 30 degree to the direction of sigma 1. Then sigma A is equal to sigma 1 minus sigma 2 by 2 sin 2 theta. So remember these two formula. So we will apply in these numericals. So let's do first numerical. At point within the earth crust, the maximum principal stress axis sigma 1. So sigma 1 is given here 120 MPa. Then the minimum principal stress, it is given sigma 2, that is your 40 MPa. Then the angle, that is given theta, it is 30 degree. Then you have to calculate the normal stress, that is your sigma n. That is sigma 1 plus sigma 2 divided by 2 plus sigma 1 minus sigma 2 divided by 2 cos 2 theta. So sigma 1 is given 120 plus 40 divided by 2 plus 120 minus 40 divided by 2 into cos 60 degree. It will be 80 plus it will be 40 into cos 60 will be 1 by 2. It will be 100 MPa. So it will be 100 MPa. So these are also two similar type of problem. Now you can pause and try to solve this. So next, at a point the maximum principal stress, it is given sigma 1 is given 100 MPa. Then sigma 2 is given 60 MPa. Theta is given 45 degree. Okay. Now remember, when theta is 45 degree, then sigma n will be only sigma 1 plus sigma 2 by 2. Because if theta is 45 degree, then cos to the 2 theta will be 90 degree. Then cos 90 is 0. So only left with sigma 1 plus sigma 2 by 2, that is 100 plus 60 divided by 2 will be 80. Will be 80 MPa. Next question, the principal stress at a point sigma 1 is 120 MPa, sigma 2 40 MPa, determine the shear stress. So I have to calculate the shear stress, direct put the formula sigma 1 minus sigma 2 by 2 into sine 2 theta. Sigma 1 is given 120 minus 40 divided by 2 into sine 60. So this will be 40 into sine 60. So sigma S will be 34.641 or 34.64. Next, similar type of question. These are for your practice. So rock element under sigma 1. Sigma 1 is your 150 MPa. Then sigma 2 is given 50 MPa. Then theta is given 30. Sigma n will be, directly put this thing, 150 minus 50 divided by 2, sorry, plus 50 divided by 2 plus 150 minus 50 divided by 2 into sine, sorry, cos 60. Theta is 30. 100 plus 50 into 1 by 2. will be 125 MPa. Then a rock is subjected to sigma 1, that is sigma 1 here given is 90 MPa. Okay, sigma 2 is given 30 MPa. So here we have to calculate the theta. So sigma n is given 75 MPa. So it will be 75 MPa equal to your sigma 1 plus sigma 2, that is 90 plus 30 divided by 2 plus your 90 minus 30 divided by 2 into cos 2 theta. So you have to calculate the theta here. So it will be 75 60 plus it will be 30 cos 2 theta. So 15, 75 minus 60, 15 divided by 30 equal to cos 2 theta. So this implies cos 2 theta will be 1 by 2 or 0.5. That means 2 theta will be 60 degree, means theta will be 30 degree. That will be 30 degree. So let's come to another type of problem, that is your phi scale. So first I'll recall the formula. Phi equal to minus log d base 2, or you can say d equal to 2 to the power minus phi. So we'll be using this formula. So remember, so sediment sample contains 3 dominant grain size population with phi value phi 1 minus 1, phi 2 2 and phi 3 4. So first we will convert this thing into diameter. So phi 1 is given minus 1. So diameter will be your 2 to the power minus phi. So we'll take d1 here. 2 to the minus phi, that means 2 to the power minus 1. So it will be 2. Then similarly we will calculate d2, 2 to the power minus 2, it will be 0.25, and d3 it will be 2 to the power minus 4 equal to 0.0625. Now d1 is your 2, d2 is your 0.25, d3 is your 0.0625. Now their weight percent is given 20%. So weight percent is given 20%, 50% and 30% respectively. So first you have to convert each pi value into grain diameter. So we have already converted each pi value into grain diameter 2 mm, 0.25 mm and 0.0625 mm. Then we have to calculate the weighted mean diameter. So the formula for weighted mean diameter will summation of I1 to N Wi di. So now we'll put this thing 2 into 0.2 plus 0.25 into 0.5 plus 0.0625 into 0.3. So then D bar will be 0.5437, or you can take up to 2 decimal 0.54. The answer will be 0.54. Comes to next problem, that is the two sediment sample A and B have mean grain diameter of dA and dB. So their combined phi value differs by 2 units such that phi B plus equal to phi A plus 2. So you have to determine the ratio of dA by dB. So it is given phi B equal to phi A plus 2. So you can write down in place of phi B, you can write down minus log 2 dB. In terms of phi, we can write down minus log 2 dA plus 2. So I'll change the side. Log 2 dA minus log 2 dB will be equal to 2. Then log dA minus log dB, it will be log 2 dA by dB equal to 2. So it will be dA by dB equal to 2 to the power 2. So dA by dB will be 4. Will be 4. Let's move to another type of problem, where is your Reynolds number. So Reynolds number, it is a dimensionless quantity which is used to determine whether a flow will be laminar or turbulent. So it is calculated by this formula. So Reynolds number, you have to rho V and take D by mu. So R is your Reynolds number, rho is your density, V is your velocity of the flow, D is your depth of the flow, and mu is your viscosity of the flow. So we'll solve this problem on the basis of this formula. The river channel carries a water density. The density is given here. Rho is given 1000 kg per meter cube. Then under dynamic viscosity it is given dynamic viscosity is similar to viscosity. Okay. Then there is another parameter, kinetic viscosity. Remember here, kinetic viscosity, that is your mu by rho. Kinetic viscosity, we use this short from this, or the symbol is used like this. So it is mu by rho. So viscosity is given 1 into 10 to the minus 3 Pascal into second. The mean velocity, it is given, velocity is given 1.2 meter per second. Then the flow depth is given, D is given 0.8 meter. Okay. So all parameters is given. So we'll have to calculate the Reynolds number. So formula is rho V D divided by mu. So rho is given 1000. So you see, all are in past SI unit, so you don't have to convert anything. So in this type of problem, you have to carefully check whether all are in same unit or not. If they are not, then you have to convert. So 1000 into 1, or direct write down 10 to the minus 3 into 1.2. Sorry. 1000 into V is your 1.2 into D is your 0.8 divided by 10 to the power minus 3. So it is a dimensionless quantity. There will be no unit here. So now we will calculate what will be the answer here. So answer will be 960,000. So now you can comment that whether this flow will be turbulent or laminar. Okay, let's come to another problem. In the laboratory fluid experiment, the Reynolds number is kept constant. So Reynolds number is given here 5 into 10 to the power 4. So fluid density, it is given same as 1000 as the previous problem. Viscosity, it is given 1.25 into 10 to the power minus 3. Then flow depth, it is given 0.25 meter. So we have to calculate the velocity. So formula rho V D divided by mu. So velocity will be R into mu divided by rho into D. So R is given 5 into 10 to the power 4 into mu is given 1.25 into 10 to the power minus 3 divided by rho is again 1000 into D is given 0.25. So all are in same unit. So don't need to convert anything. So now we will only calculate. So this much will be 62.5 and it will be 250. So answer will be 0.25 meter per second. The velocity will be 0.25 meter per second. Next, a river has a flow velocity of 2.5 meter per second and average depth which is 1.6 meter. We have to calculate the Froude number. So what is the formula of Froude number? B by root over of GD. So B is same velocity, B is your depth, G is your acceleration due to gravity. So flow velocity is given 2.5 meter per second. It is in meter, so all are same unit. In G will take 9.8 meter per second square. So root over of 9.8 into D is given 1.6. So it will be, this will be 3.95 with 0.63. So answer will be 0.63. So according to Froude number, we can also classify different type of flow. If F is less than 1, the flow is called as your subcritical. If is greater than 1, it is called supercritical. If is equal to 1, is called critical flow. So this flow will be subcritical because it is less than 1. Next, during sediment transport analysis, a flow is observed to be critical. That means F equal to 1, a channel depth of 0.45 meter. So you have to calculate the critical flow velocity. So F is equal to 1, depth is given 0.45 meter. So G will take 9.8 meter per second square. And in question it is, if it is given G equal to 10 meter per second square, it will be more easier. So, but as it is not given, we have to take 9.8 meter per second square. So you have to calculate the V. So F equal to V by root over of GD. So as F equal to 1, then V equal to root over of GD. So 9.8 into 0.45, 0.45, the root over will be 2.1 meter per second. So V will be 2.1 meter per second. So next part will be coming soon. So please subscribe the channel so that you never miss the numerical series part. Thank you.